Independent educational content. Views and opinions are entirely my own and do not reflect the official policies or positions of Akamai Technologies. All right, welcome everyone. You ever just pause and wonder how the internet actually manages to stay upright? I mean, think about it. Millions of people are simultaneously streaming a massive live championship game, while at the exact same time, the network is absorbing colossal, coordinated cyber attacks that are actively trying to tear the whole thing down. It's kind of a miracle it works at all, right? Well, today in this explainer, we are pulling back the curtain. We're going to look at the hidden, unsung technologies that keep our digital world running smoothly. Think of it as a framework. We can call it the digital triad: infrastructure, delivery, and security.
Because honestly, this is the high-stakes reality we're living in right now. In a world where connection speeds are literally measured in milliseconds, the margin for error, it's effectively zero. Imagine the latency during a live event, or a sudden network crash when traffic just randomly spikes. Or even worse, a colossal 20 terabit per second distributed denial of service attack slamming into the servers. What do users actually stand to lose here? Basically everything. Seamless experiences, revenue, critical business continuity, data privacy, the whole shebang. It's a constant, everyday battle, and those traditional hardware solutions just sitting in isolated data centers? Yeah, they just aren't enough to handle it anymore.
So, to understand how we actually overcome these massive challenges, here is our roadmap for today's explainer. First up, the millisecond battleground. Then, flawless delivery at scale. Number 3, defending the edge. 4, securing the AI frontier. 5, the invisible traffic cops. And finally, number 6, the connected digital future. Let's get right into it.
Section 1. The millisecond battleground. Guarding the core. Okay, so you simply can't deliver a flawless web experience if your internal network is compromised. Makes sense, right? That is exactly where Akamai Guardicore Segmentation comes into play. Relying purely on traditional perimeter security is a thing of the past. Guardicore is a software-based microsegmentation solution, and it gives you this incredibly deep, granular level of visibility. It continuously discovers and fingerprints every single connected device across your network. And it goes deep. We're talking down to process-level application understanding. But what makes this a real game changer is how it uses business risk reasoning to enforce zero-trust policies, all from one single interface. Whether you're dealing with quirky Internet of Things devices or legacy operational technology systems, this solution locks the environment down so tight that if ransomware does manage to breach the outer perimeter, its lateral movement is stopped dead in its tracks. It's essentially like a submarine automatically closing its blast doors to wall off a leak before the whole ship goes down.
Section 2. Flawless delivery at scale. The last mile.
All right, so the core is secure. Now, how do we push all this heavy media to end users without digging up streets to lay thousands of miles of new cable? Welcome to the notorious last mile problem. When pay TV services simulcast a massive live event, relying on traditional unicast delivery means sending one dedicated stream to every single viewer. That will absolutely overwhelm a network. The smarter alternative is multicast-assisted adaptive bitrate delivery, or MABR. In this setup, one stream serves many viewers. By shifting to a licensed multicast solution, network operators can actually bring their peak traffic growth right back down in line with average traffic growth. It saves massive amounts of last-mile network resources and, importantly, avoids those incredibly expensive forklift upgrades to their routers. To picture how this architecture plays out in action, we have the multicast controller and generator sitting at the edge. The generator cleanly ingests your standard unicast video streams, maybe coming from an origin server or a CDN. Then, taking its instructions from the controller, it packs and encapsulates the video. It essentially converts that unicast stream into a multicast format right at the network edge, before beaming it over the optical network to the end devices. It is a brilliant, totally seamless conversion that keeps the video quality pristine without clogging up the core network.
But hey, delivery isn't just about massive live video streams. It's also about the millions of images, the short videos, and the API calls that power modern web apps. The Image and Video Manager intelligently and completely automatically optimizes visual media on the fly. It literally generates the exact format, quality, and size perfectly suited for that specific user's device. So, creating a next-gen format for an iOS device versus an Android one, it does that instantly without you ever having to touch your original code. Meanwhile, you've got API acceleration handling all that invisible, under-the-hood programmatic traffic. By caching API responses right at the edge and leveraging advanced stuff like GraphQL caching, it massively offloads the origin infrastructure. And it is so resilient, it actually comes with 100% uptime SLA, which means it can absorb those crazy, unexpected traffic spikes without breaking a sweat.
Section 3. Defending the edge. The dark side of scale.
Now, obviously,
That kind of incredible scale, it attracts bad actors. I mean, just look at that number, 20 plus terabits per second. These massive attacks have become the go-to weapon for cybercriminals, often throwing up a smokescreen for a much more complex ransomware strike underneath. That 20 plus Tbps represents Akamai Prolexic's dedicated DDoS defense capacity. Think about that for a second. It is a staggering amount of bandwidth, and its sole purpose in life is to absorb and mitigate even the most record-breaking, internet-melting attacks out there.
So when a massive attack hits, all that traffic is immediately routed straight into cloud scrubbing centers. A network cloud firewall acts as the absolute first line of defense, applying access control lists right there at the edge. The system analyzes the traffic, scrubs out all the malicious DDoS packets, and then securely sends only the legitimate, clean traffic back to the customer's origin. It handles this using generic routing encapsulation, or GRE tunnels, which guarantees business continuity without slowing anything down. It's essentially a gigantic, highly intelligent filter sitting squarely between the bad actors and your data center.
Section 4. Securing the AI Frontier, the Modern Bouncer.
As we lock down the traditional edge, we've got to keep our eyes on the new threats, right? Generative AI has introduced entirely new attack vectors. Hackers are actively manipulating large language models in ways that are totally unprecedented. To fight this, we need a firewall for AI, basically the modern bouncer for LLMs, because traditional security tools, they completely miss these AI-specific vulnerabilities. This firewall acts as a mandatory checkpoint, using API-based risk detection to scan both the inputs going into the AI and the outputs coming out. It provides prompt injection defense, so attackers can't trick the model. It enforces data loss prevention, so your AI doesn't accidentally leak sensitive corporate secrets. It filters out toxic content, and it blocks adversarial data poisoning.
And the really cool part is how adaptive this response is. It doesn't just blindly block everything and ruin the app. It operates procedurally based on risk scores. Step 1, monitor. It can just quietly log detected threats for analysis. Step 2, modify. This is wild. It can actually adjust AI-generated outputs in line, scrubbing sensitive data while keeping the conversation flow completely natural for the user. And step 3, deny. This outright blocks the really high-risk inputs from ever reaching the model. It seamlessly enforces your security policies, but the user experience stays totally intact.
Section 5. The invisible traffic cops, unsung infrastructure. All of this flawless delivery and security, it relies entirely on the foundational routing of the internet itself. And to give you a real sense of the scale we're talking about, the auth-serve authoritative DNS server uses this totally unique in-memory version database. It is capable of storing over 1 billion resource records. 1 billion. It's specifically purpose-built for the massive explosion of connected devices we're seeing, ensuring that when you type in a website, the underlying address information is fetched with literally unmatched performance. But let's be real, scale means absolutely nothing if the system crashes. Historically, master authoritative name servers were a massive single point of failure. Offserve solves this with active-active dual mastering. Basically, two active servers master the exact same zone, automatically syncing their updates, so there is zero downtime. On top of that, it completely automates the lifecycle management of DNSSEC. This is super critical because DNSSEC cryptographically protects DNS data, and back in the day, a tiny configuration mistake used to cause massive brand domains to just mysteriously drop off the internet. Offserve takes all that complexity and automates it away. So, once DNS actually finds the destination, how does the traffic get there efficiently? Enter Global Traffic Management. Think of GTM as a dynamic, hyper-aware GPS for internet traffic. When your browser requests an IP, the DNS resolver queries the name server, which replies with an alias pointing straight to GTM. GTM then calculates the optimal route, but it doesn't just use geography. It looks at real-time internet health, network latency, and data center load. It instantly routes users around network traffic jams and server outages, returning the absolute best IP address so the user connects transparently. And it happens in the blink of an eye.
Section 6. The Connected Digital Future. We have covered a tremendous amount of ground today. Flawless media delivery, ironclad security, and highly intelligent routing infrastructure. They aren't separate, isolated concepts. They are deeply interconnected layers. As we move from simply balancing traffic to actively injecting zero trust and AI firewalls right at the edge of the network, I want to leave you with this thought. As edge computing evolves, how will autonomous AI threat detection and deep microsegmentation further redefine the ultimate limits of the internet's invisible infrastructure?
The technology we've explored today is incredible, but it's really just the beginning. Thank you so much for joining me on this explainer, and keep questioning how the digital world around you actually works.